So, hi, greetings from Munich. Yeah, I want to give you just a brief overview over SommR. So, yeah, let's start with I would just want to give you an overview of what SommR is actually about, because I don't know if any of you guys have an idea. So, let's have a look at the higher level building blocks. So, the mission statement for SommR is basically to use some IP Rust implementation and provide that to different apps written in different programming languages. And this is basically done via the SommR protocol, which is like a common interface, you can call it. And this SommR protocol is like used for distributing inquiries or requests from different apps to a centralized SommIP daemon process. So like here, you see a basic topology consisting of two ECUs, and each ECU is running a centralized SommIP daemon process. And this daemon process just takes requests from the consumer, for example, or the producer, and forwards this to other daemons. So let's take, for example, the producer B, so the green ladder you see over here. It's, for example, a Rust application, and this producer wants to offer the service B. And therefore, it just uses the SommR protocol to forward the request to the centralized SommIP daemon. And this SommIP daemon is responsible for all SommIP activities on this ECU. And then the SommIP daemon will relay this request to another ECU, and, for example, then offering this service to the consumer B, which you see here also in a green ladder. And this could be, for example, a C++ application, and we also want to support a Java application. And just regarding SommIP, which you might not know, so this is basically the de facto standard for inter-ECU communication in the car. So it it's like for infotainment, but also for non-safety relevant functions like seat adjust or ventilation. Exactly. So, and now we had a little overview over the higher levels, but let's dive into the low levels. So this is basically what an application has to do to use the SommR protocol and to get requests going on. So what the application code at first wants to do is use an API from the generated core code, which the services should be used. So we basically generate for services a code, and this code basically then contains calls to our SommR library. And the SommR library basically just includes like requests like offer the service or find the service, subscribe to some events and stuff like that. And these requests are then relayed to the centralized SommIP daemon, which you see below. And the SommR library and the SommR daemon are communicating just with TCP or Unix domain sockets. And yes, the communication from daemon to daemon is plain SommIP. That's the important point. I can talk a lot about that later on, but that's just briefly the overview. So now I want to give you an update what has been achieved so far. So okay, this is the mandatory slide, I guess. So obviously it's under active development. So there are currently 9 contributors. Those there are half from Carriot and half from ESR Labs, and some other speaker mentioned the North Star container runtime. So this is also done by ESR. So yeah, greetings to the ESR guys. So in total, there are approximately 800 commits, and they are split into 3 parts. So there's first the overall daemon, so which is responsible for collecting the request and relaying the request to plain SommIP. Then we got the client libraries, which are used to talk to the centralized daemon, and of course the code gen, which is then used by the application. All right, so a little bit about the things which have been achieved so far since the last update. So basically 2 pillars were major achieved. So the first one is like basic stabilization, and the other one is testing. So regarding stabilization, there are 3 points which are now finalized. We got a service discovery running. So this is basically responsible for offering services, finding services, subscribing to events and something like that. Then we got our first whole SommIP communication paradigm done. It's like RPC calls with request in response. And then we got a Rust client API settled. So this was the first block, and the other one is just testing. So we decided to implement our own test harness for the daemon. So what I mean by that is because there are so many stuff which can be automized, like setting up network namespaces, doing the configuration for that, starting like the centralized daemon process. So therefore, we wrote a Rust macro, which does it all for you. And every integration test is using basically this common setup routine. Exactly. Then, as I mentioned here, we're carrying out a lot of integration tests. So like this is a black box testing of the daemon. So like throwing a lot of messages against the centralized daemon, and then look how he interacts with that. So this were basically the 2 pillars which we so far achieved. Now let's talk a little bit about the project outlook. So we have to make our implementation SommIP feature complete. So SommIP events are partially implemented, but there's still some stuff missing that's have to be done. And then currently we're also working on a Java client API. So the Rust one can be used, but Java is missing. All right, so this was basically just my brief overview. I guess I have some time left. So are there already some questions, or should I proceed with some backup slides? I think I just go on with some backup slides, so you guys understand a little bit about the protocol a little bit more. So as I said, the SommR protocol is basically used between an app which wants to use a centralized daemon and, as I said, the daemon. So this communication can be done via TCP or Unix domain sockets. And the SommR protocol is really lightweight. So every protocol message is, yes, most protocol messages are done and split in metadata and a payload. And the metadata is basically consisted of 3 fields. So you got a message type. So this basically represents the request, which should be answered by the daemon, then a header length and a payload length. And the header basically is variable due to the fact that we got different message types. And then we also got the payload length. And one important idea is that the actual serialization and deserialization of the payload does not happen in the daemon, but it's only done via the app. So the serialization logic, in the daemon is really lightweight. And another point of that is like the SommR protocol messages follow the SommIP serialization format. So it's type length values. So serialization, like from structs, you got different tags for the members of the struct, then a specific length which indicates how long the values are, and then the value itself. Exactly. That was just a brief overview over the SommR protocol. And now, finally, I want to give you a brief overview over the messages which are contained in the protocol. So the first one is just a basic heartbeat between the app and the daemon. So this ensures the connection is up and running. Then we got the offer service message. This reflects a little bit of the SommIP message flow. So you got the offer service, which just says the app wants to announce a service via the daemon. Then you got the reciprocal, so the service, a search service, which is just there. So the app wants to find a service. And then we got like 2 commands for the RPC method, so the request and response message. And then we can also command the daemon to subscribe to an event group. This is done via the subscribe, and the subscribe result will just basically indicate if the subscription was valid or not. And the last one is like just basically sending events from the app to the daemon. All right, that was it from my side. Thanks.
Simon,
Thank you very much. I can hear you, yes.
Great. So I was just curious how many additional backup slides you may have, but I think that's fine. We have questions here in the audience, so just take the microphone.
On one of your previous slides, you showed us how an application would interact with SommR. And I think there was some IDL-generated code in there. And my question was, is that always strictly necessary, or is there also a generic API where you maybe can use some, I don't know, something like write bytes, read bytes, I don't know.
Yes, so currently we want to follow that. Like we got like in protobuf, like a proto file and generate stuff from that. It's like RXML used by us. I think currently we want to use that because like in Audi and something like that, it's the common routine. So I think the plan for us right now is like to stick to that.
So the data that you send over SommR is always conforming to some IDL? Is that what it always has to do, or okay?
No, that's just the payload. So the payload must obey the services defined by the IDL. The basic protocol messages, of course, are just defined by the SommR protocol itself.
However, then encoding the payload so that it complies with encoding the payload so that it complies with the spec is too hard to do, or why do you enforce using an IDL?
Yeah, as I said, it's just a basic routine currently used in VW. So I think we just wanted to stick to that process.
Okay, got it. Thank you. Okay.
Yeah.
Okay. Any other question? So, applause for Simon. I hope you can hear it. Thanks for your presentation.
Thanks. Thank you. Thank you very much.